Today we're going to learn about functions. So currently we just write all of our code in one spot, and as our programs become bigger and bigger and more sophisticated and we add more features on, the size of the program is clearly going to increase. And at some point it's going to be very hard to maintain and hard to read through it. You could put an entire program just in one file with no other functions, but it's not going to be the greatest. Something we can do to make our programs a little bit easier to read, a little bit more organized, is something to make it more modular is something called modules, but more commonly these days they're known as functions. So by using a function, or by writing multiple functions, we can delegate tasks out to other portions of the program, passing input as data to the functions, and possibly receiving some kind of output as a result from the function. So, a function is just a way we can write a set of code, just as we've been doing, but we put that code under a name, like a function definition with a function name. So, for example, we could have get user input or some numbers, and anytime we need to get user input, we could just call this other function. It handles it for us, and then we only need to implement how to get user input one time. A function can be called by its name, and the program flow is going to jump over to that function, execute its code, and return back to the original spot when done. So if you imagine this rectangle is the main program, and we get to a function call, it hops over to a different block of the program, executes its own instructions, and returns back to where it was to continue the program flow. So let's say we did write a program with a function to get the user input, and at the moment this isn't in a function, but let's say we wrote it first and then we're going to move it into a function. We have, while the user input is invalid, display an error, get the user input again. We have a loop to contain that, and then we have some valid input at the end. Well, we don't want to have to rewrite this every time we need user input, so we could throw it in a function. So if we did just use this as it was, we could copy paste everywhere. That would create a lot of duplicate code, and it would give us possible errors. So another reason you wouldn't want to just copy paste this code everywhere is that you would then have to update it in all positions if you're going to make an update to that logic. You also just generally should avoid having repeated code, because there are ways we can cut down on having the same code written multiple times. And of course, whenever I do copying and pasting with code, I have a tendency to make an error and miss something as I'm adjusting it for each new area. So if we just have it written once, we avoid that copy-paste issue. So turning this pseudocode here into a function, we have a function named getInput, and because it could be used all over the program and there could be different minimum and maximum values if we're thinking of a number menu output, we could have a min val and max val as inputs required. So we could say, okay, for this first menu you can do 1 to 10, for this other menu you do 1 to 5, and we can pass that data in. We get the user input. And while it's invalid, where if the input is less than minimum value or input is greater than maximum value, display an error and get the user's input again. And once this while loop is over, that means we have some valid input and we can return it. So anytime we need to get the user input, we could say input variable is equal to get input 1 through 5. So let's say we had a main menu that had 5 options. And we just run this one line to execute all of this, and then we don't have to add any more extra code at this point. So, how are functions made? Well, when we design about functions, we need to think about a few things, such as from the outside, what kind of information does the function need, such as what are the inputs, if any? What kind of information does the function return? Or what are the outputs? And what is a descriptive name to describe what the function does? What is the function's name? So you might have had functions in math before, and those look like this, where we have f of x is equal to 2x plus 1. And in this scenario, we have a function named f, and it takes x as an input. Then in the function body, it calculates the result of 2 times x plus 1. So whatever you plug into x, it could be, if you put f of 2, it'll be 2 times 2 plus 1. If you did f of 3, it would be 2 times 3 plus 1. This is the input variable. This gets calculated, and then it becomes the result. The output is the math operation. So we can also implement this same function in programming. So here we're defining a function in Python. We use def f of x. So f is the function name. Usually we'll have better, more descriptive function names. Here's x, our variable, and it's going to return 2 times x plus 1. So whatever x is, it will do this math operation and return the result. So sometimes in our programs we can write functions that do math for us, but that's not the only thing we might need. So for example, here's our f of x. Here's a function that calculates the area of a rectangle for us. It takes in a width and height. It has the formula as width times height, and whatever that returns is the result. Then we have price plus tax. This function will take in a price of an item and the tax rate, and then it will basically add how much extra tax onto the price and return that. But besides just doing math, we could also use functions for other things, such as displaying a main menu, so we don't have to have all these print statements inside of main or our main program part. We can just say display menu. We can also write a function to get the user input, just like that pseudocode. So we define a function named getInput. It takes in a minimum value and a maximum value as the inputs. We have a choice variable inside. We ask the user to enter a value, and it's an integer. Then we do a loop while the choice is less than the minimum value, or the choice is greater than the maximum value. Then we'll display an error message and ask them to re-enter their selection. Then once the while loop is done, we return their choice. So this function gets some valid input, and we only need to write it one time, and then we can use it everywhere in our program. And another example could be, maybe we need to format some data before printing it out to the user. So we have here define display money. It takes in some balance. If the balance is less than 0, it can print out the balance and then a message overdrawn. Otherwise, it will just print out the balance. So maybe we need to do a little bit of pre-formatting just to make things look nice for the user before we actually output it directly. So you can tell what is a function based on its parentheses. We have a function definition. We need parentheses at the end of the name. When we're calling a function, we need parentheses at the name here. And also the input and the print, these are both functions. We've been using these functions. So print takes in some text that's going to display to the screen. Input takes in some text that it will ask the user before getting the input and returning what they wrote. So in Python, you can create a function like this. We have defined my function, input 1, input 2. We're just doing some little math operation, value equals input 1 plus input 2, and returning a value at the end. So with our functions, they must start with def in Python. So we're defining a function. We can give it a name. It can be named anything as long as it matches naming conventions like our variables, so no spaces. It can have text and numbers, and probably cannot start with a number just like a variable, but could have underscores in it. Then we can specify input values. So here we have input 1, comma input 2, two different variables that it has. If we had no inputs, we would just leave this blank, but we'd still need the opening and closing parentheses. Then inside, this is the function body, and if we want to return some data, we need the return keyword, and then what we're going to return. But this is also optional. If we have no return, we just don't have a return statement. We just do whatever we're doing on the inside. So again, anything inside of the function is part of the function body. This is what the function does. So let's look at some different kinds of functions we can write. So with this one here, we have our display menu. It has no input that it takes in, so this is empty in the parentheses. It returns no output, so there is no return statement. And all it does is print a nice number menu for us. So that's what this will look like from the definition side. And then calling it, we'll say display menu. We need to have those parentheses at the end. It's not returning anything, so this is all we need, the entire command, to just call that function. So calling the function means we're running in our program, we hit a function call, we jump over here, we execute this, and then return back to the program. Here's another function. This one takes input but returns no output. This is our display money one, where it takes in a balance and it will print balance with overdrawn or just balance by itself. And it has no return statement. It does not have any output. It just has input. So over here we have display money. We can pass a literal into it, which means we just pass in like a hard-coded number value. We have 13.37. Or if we had a variable with some data in it, we can pass that variable into the function, and this copies the 123.45. It goes in here, and then it copies it over to balance, and then now balance will have 123.45. So that's how the inputs work. Here's another function where we have inputs, width and height, and it returns an output, return the width times the height. So when we call it, we have area 5,3. These are some literals, integer literals. But for this one, since this returns data, we need a place to store that data. So we've created a variable called result. Result is equal to, and then we have the function call, area parentheses 5,3 end parentheses. Here's another example using variables. So we could have a width and a height. And then we set the result of area to A, so area is equal to W comma H. And again, whatever value is in W and H, those get copied over here. These aren't the exact same variables, these get copied. Okay, so when we are defining a function, when we have these inputs, these are variables, but they're also known as parameters. These are inputs that we are expecting to receive when the function is being called. We need width and height. When we're calling the function, the values we pass in that will be copied over to the corresponding parameters, these inputs are called arguments. They're the values that will be copied. Okay, let's look at how this would look in flowcharts. So before we had a circle with program begin and it would run and do some operations. Now we're going to start writing our main program flow inside of a main function. And when it wants to call a new function, we'll have this box. So this box has an extra line on either side. It has the name of a function. And then we can just define what that function does with its own circle. And then, normal code as we would usually put it, and an end at the end of the function. So this would start, call hello, display hello world, end, come back over here, call goodbye, come over here, display goodbye, end, return here, and then the program ends. So these boxes with the extra lines are the function call, these are the function definitions. And again, the program flow just hops over here, runs all that code, and returns back to where it was. So whether we're calling hello or goodbye, it operates the same way. It calls the function, executes the code, comes back. And with pseudocode, now there's not really an exact way to write any pseudocode. As long as you have the language to describe it, it should be fine. But we need to at least make sure we're specifying a function name, like get input, and then the input variables and the output, if there is any. So in this pseudocode, I just say function, here's get input, min, max value, and then you can kind of write your pseudocode as normal. When I'm saying that we're calling it, I just wrote assign user choice to the result from get input 1, 3. Really, this should be 1, 4, because it goes from 1 to 4 for the program options. So I can fix that really quick. It should be that. Now about this main function that I mentioned. So with Python, our program begins as soon as we write some code. If I bring over this test file I was working with, these, well, those are some function definitions, but if I just said print hello, clearly it would just start executing from the first instruction it finds. However, because after like an introductory programming class, you'll probably be using something like C++ or C# or Java, we tend to try to emulate that a little bit in our Python code. So what this means is in C++ and C# and Java, every program starts at a main function. That's just how those are structured. So here is some C++ code. This is a main function. It has code inside of it and returns 0 at the end. We're not going to worry about what the C++ code here does, but we're going to kind of work the same way so you get used to that idea. So again, we're going to start writing a Python function called main and write most of our program inside of main, and then also add other functions on top of that. So let's say we define our main function. It does not need to take any parameters, and it doesn't need to return anything. It can just have code for the program. This program just asks for your name and says hello. So this is the function definition. Then at the bottom of the program, we will call main just by saying main with the parentheses. Make sure it's not indented. It has to be at the very first level, no indentation. So we call it when the Python begins. When Python starts, it sees the function definition, but it doesn't execute the function definition. It's going to come down here, see that we are calling main, and then come back up here and execute it. So for an example program, we would have our main defined at the top. Make sure you put it at the top so it's easy to find. We can also have other functions defined. So here I have a menu and a get input. And then at the very end of the file, we call main to get started. Now when we look back up here at main, it says done is false. While we're not done, call the menu function. So it's going to display the main menu. Get the choice. So choice is equal to get input 1 through 4. It'll get the user's choice and return that. And then we would end up adding onto this with some if statements. But that's how that would be formatted. So main acts as the core of our program, where everything is initialized and the program flow is defined. We can delegate tasks such as printing the menu to other functions by calling them. So by separating out these different pieces, we've made the program easier to follow and read by having here, we're doing a menu here, we're getting input, rather than having a bunch of code inside of main. So following this sort of design, we can eventually write larger programs. It'll be easier to add on to, and it'll be easier to debug once we get to that point. All right, now we need to talk about variable scope. So that variable scope refers to where a variable can be accessed. So if we had this example where we have main, we're going through, we call get area over here and then return and end. Where are variables in main used? Where are variables in get area used? So there are two types of variables for now. We can declare them outside of any functions or inside of a function. So here we have done inside of main, and we have choice inside of mains and inside of the while loop. Up here we have pi, and it's outside of all functions. It's declared out in the global space. So if we declare it outside of all functions, it is global. though usually using global variables is a bad design, so we're going to minimize our use of that. And inside of main, we declare these inside of main, so they are local to main, and they're known as local variables. So whether we're declaring variables as part of input parameters for a function, or inside of the function body, these variables are local to this getInput function. And when we have specific variables declared inside of an if statement, or an else if statement, then they can only be used inside of those specific code blocks. So for instance, D here is declared within the if a is less than 0. So D is local to this if statement, and it cannot be used out here, can't be used up here, can't be used further down. It has to be inside of the same level it was declared at. Similarly, this E is declared in the else if statement here. It can only be used inside of the else if statement. However, these A, B, C variables, they belong to my function. They can be used anywhere inside my function or inside of its own sub blocks, so inside the if and the else if statement as well. Okay, so let's look at splitting our programs into multiple files. So again, as our programs get bigger, it'll make it easier to read if we put specific types of functions into their own files. It helps us keep everything organized, and it lets us maintain and debug it easier. So usually we'll have main in a main.py or main.py file, for example. And then we would want to group like functions into their own files. So for example, if we had a bunch of functions that did math operations, that could go in math.py. If we had other functions doing menus, different types of menu stuff, those could go in menus.py. So if we are going to use multiple files, and one file is using functions from a second file, we need an import statement. So here we have two files, main.py and functions.py. Functions.py has some functions inside of it, defined inside. And then main.py is using that function, this display menu function. So because of that, we need to make sure to have an import to this function file. So we say from functions, import star asterisk. This means everything. And then this functions here has to match the same file name. We don't need the .py. We just need this to match functions. So then we can import any functions in the second file over here. Now note we don't need this the opposite way around. This file is not calling main, so we don't need an import. And these imports should be in one direction. We should have this importing that, but not both at the same time. Okay. So I was going to split out an existing program into functions and into separate files as an example. So let's look at that. So here I have in here I have a bank program, and it's all within main basically, or all within one file. We haven't split anything out into functions yet, but we'll look at how to do that. And here's basically the code for now. We'll do the same thing with the code and split this out. But basically we start the program, we set the balance to 0, so we have a bank account balance, and we set done to false because we want to continue looping until the user chooses to quit. Then we look at, is the program running? Or in other words, is done equal to false? If it's equal to false, then the program is running. We are not done. So if this is false, basically done is false is false. If done is true, I know that's kind of like a weird double negative, but if this evaluates to false, that whole thing here, then we're going to quit the program. But if we're running, done is equal to false, so we display a menu, We get the user's input and put it in choice. We ask, is choice valid? And we do that whole loop to see if we have a valid value. If it's invalid, get it again, check it again, and keep looping until we have something that's valid. So this should have false down here. If it's not invalid, then it is valid. So then if choice is 1, we'll say, hey, how much do you want to deposit? Add that to the balance, and then we're going to return to the top of the loop and start everything over again. If choice is 2, we'll ask them how much to withdraw. If their withdraw amount is more than the balance they have, it will display an error message, and then we'll just return to the top of the program up there. Or if their amount, the withdraw amount, is less than or equal to the balance in their bank account, then we can subtract that from the balance and then return up here. Otherwise, if they choose to quit, we'll say done is equal to true, and then technically it'll return back to the top here, and this evaluates to false, and then it ends the program. And lastly, just as a note, with this, to validate input to make sure it's between 1 and 4, and these if statements, technically this should never happen. We should never get something that is not 1, 2, 3, or 4. So this part is logically impossible. So I didn't put any blocks in there. So all of this is inside of basically one program file and one function. So we will want to split these out. How do we do this? Well, let's start by splitting out our get input part so we can kind of simplify that. So over here, we're going to call, let's say, choice is equal to get input. And we're going to separate these parts out. So we can actually, let's delete this arrow, delete that arrow. We're just going to grab this chunk of code. Oops, I accidentally grabbed a whole arrow over there as well. We'll grab this chunk of code and move it into its own function. So we're going to name it get input. We'll do get input. And we'll come back here. So the idea is we want to delegate the whole process of getting input, validating that input to somewhere else. So get input, and then once we return from the function, we know that the input's going to be valid. So we can color this. Let's give it a background color. Just light blue. We'll make this light blue. Okay, so to set up the function, we're going to need a min value and max value. So those will be inputs. We'll ask the user to enter their choice. We can keep the same thing here. And instead of choice is less than 1 or if it's less than 1 or greater than 4, which is the max, then we will display it's invalid and try again. In this case, if it is not invalid, instead of continuing on with that whole program like we were before, we're going to say return choice, and then the function basically ends at that point. So this is over here now, that's its own function. When we're executing the code, we come here, it basically comes over here, and then it will come back. So that's how that technically will flow. Okay, now let's split out another part. Let's say we have the display menu. Well, this is only really one block here, but technically that'd be a bunch of prints. So I would just move that over here. We'll say this is display menu, and then it just ends at the end. And we can swap, oops, we can swap this part with the function call. So display menu. And we'll redirect these arrows. And maybe set this one to yellow. I don't remember which yellow it was, but close enough, right? So now we have two functions defined all the way over here, and then those would be in possibly different files somewhere else, making things less cluttered. Okay, so before we continue, let's go ahead and do this from the code side. And let me open up the folder where I have this. So this is the main.py file, but I don't have a main function in here yet. It does the same thing as that flowchart, but we have display menu here and we have choice over here. So let's start splitting these out. I am going to create a functions.py. We'll just keep that as its own thing. We're not going to have a ton of functions, so we're just going to have 2 files. If I want anything from the functions file, then we're going to have to import it in here. Okay, so if we want to include functions from over here, we have to add an import statement. Then we add a import statement, so from functions import everything. This will allow us to add everything from what is in here. Currently there's nothing, but we can define these functions. Let's go ahead and take the main menu. We'll bring it over here, say define display menu. Those can all be printed out like that. We can then over here call display menu. So this is the function call, and this is the function definition. Now when I run my program, I need to make sure I'm running from main, because if I run from functions.py, it's not going to do anything. If I run it from main, it'll show this right here. Okay, so the main menu is being displayed. It's coming over here and calling that. Now let's take the input validation. So define get input, min val, max val. We'll paste this in. We have to readjust choice less than 1, choice greater than 4. So we have a choice here, and we have to add one more thing. At this point, choice is valid now. So we will return the choice. We have to make sure to return it if we want to access that data. So over here, we'll just say choice is equal to get input from 1 to 4. And now we run it, and it will still let us do the choice. Now the program doesn't look any different than it did before. I could have had these functions, you know, everything here as was, and it would have looked exactly the same to the user. But for us, now things are going to be a little bit more organized. Okay, so now we have a few more things that we can split out. I would split out each of these operations into their own little functions, and let's look at how that would look in the flowchart first. I just have to find the flowchart button. There it is. So we have 3 main operations: depositing, withdrawing, and displaying the balance. So let's make functions for each of these. We'll start with do a deposit. Let's do a withdraw and display balance. Now, what kind of inputs do we need? Well, for display balance, we really only need the balance variable, so let's make sure to add that in here. It needs to be able to see what the balance is to be able to display it to the screen. We'll take the display balance command and move it here, and this really, it just is displaying some information. But it can be a little bit more nice to see a description of display balance as what we're doing here. So we'd call display balance, passing in the balance, instead of like, oh, here's a bunch of print statements, even though this one was not a very long print statement. Let me try to fix these arrows. That's not looking quite like I wanted it, but this will be okay. So display balance, let's change this one to orange-ish. Do this orange. I know that's a little bit hard to read, but there's that one. Okay, so for deposit, we need the user to enter a deposit amount and store it in an amount variable. We don't need to pass that in. We can ask them to do that input from inside the function. but we do need the balance so we can do some math. So for deposit, we also need the balance. Let's set this one to a green. It'd be nice if they had lighter colors. There we go. So in here, we're going to ask the user to enter an amount to deposit and add that to the balance. And end. So over here, instead of calling these things, we'll just say we're going to deposit and pass in the balance. So we're calling the deposit function, and we're going to pass in whatever the current balance is, and then it will do the operations based on that. Okay, and finally withdraw. Again, withdraw needs the balance, but we can put the amount inside of this function. So we'll set this to the pink color. We'll take this logic. We'll move these over a little bit more so we have more space. Withdraw, ask the user to enter an amount. We could do a different validation, but we won't worry about that right now. Here, let's do it this way. Subtract the amount from the balance, and then we'd have an end. Okay, so if we say we cannot exceed the balance, then we can go backwards and just end. Okay, so if the amount is greater than the balance, we can say cannot exceed balance and end the function. Here we need to make sure this has balance here, but then it will modify balance and then end the function. So we'll erase these, and we'll just say withdraw. We have a balance. Don't need this line anymore. And we'll set this one to that pink color, and it will return when it is done. So now this flowchart is simpler looking. It's a little easier to follow. We start the program. We have main. Start the program, display the menu, get the input. If they chose 1, we are depositing. If they chose 2, we're withdrawing. If we chose 3, we're displaying the balance. If they chose 4, we're going to set done to true, and then it will continue its loop. And then over here we have our different functions all defined, and you can see that they do very specific things. So in our Python files, let's do the same thing here. Let's do display balance. It takes in a balance as the input, and we can take this part, bank balance. Your balance is such and such dollars. That's defined. It doesn't return anything. And then over here we will say display balance and pass in that balance. So if I run this and say view, it'll say $0. Let's go ahead and set this to 100 just for a test. Okay, deposit money. Let's do define deposit. We need a balance. We'll just take this code, put it in here, and we need to make sure to, well, we can set it like this for a moment. Let's say if we're doing that, we're going to deposit and the balance. So when we run this, let's look at view balance. It's 100, deposit 50, view balance is still 100. So because I don't have a return here, it's not going to let us update this balance. It makes a copy of the balance. It copies it here, adds to the amount, but then over here, the original balance does not get changed. So we could return the new balance, and we can say balance is equal to the deposit. Now if we run this, we'll say view the balance, it's 100, deposit $50, view the balance now, it's 150. And we can do the same with our withdraw. So define withdraw, balance, we'll take this, move it over here, and we need to make sure to return the balance at the end. So balance is equal to withdraw, the balance, And now our program is a lot smaller here. We'll run that. That doesn't do anything. Run this. This will work still. Withdraw $50, and it's 50 left over. Now let's go ahead and make the main function as well. So all we need to do is say main, define main, and tab all of those over, and then make sure at the beginning of the program we start main. If we didn't have this here, when we run this, nothing happens. We need to make sure to call main. And then we can run, and the program will work as intended. So we can view the balance, we can withdraw, view that balance, we can quit. Okay.